So sorry, break is already over, but I hope you all had a nice time. Hope you were able to spend time with friends and family and enjoy yourselves. Anyone gonna watch Rogue One over break?
It
sucked. What?
It was amazing.
Dude.
It was decent, but it wasn't the best song.
You what? So just so you all know, I am. Yes. Why wasn't he in the movie? Because he was still on Tatooine. And then you was looking for him. You? Alright, you got some life.
Yes, I did. Like if he didn't die.
Oh yeah.
I think it would have been better off.
Yeah, that could have been. Alright, so I am a huge Star Wars geek. Now I'm not as big of a geek where I'm reading every book that was based on, characters that didn't develop from other people. But I'll tell you what, I remember, I think I probably shared this all with y'all, but when Star Wars, the 1977 version first came out, it was not titled A New Hope, and it wasn't titled Episode 4. But when it first came out, my mom and dad and I and my sister, we were in Omaha, Nebraska, we were in Lincoln, Nebraska, at my uncle's house. And my dad and my uncle took me, my sister, and my two other cousins to go see a movie called The Rescuers. And then that night, Star Wars was also released, and it wasn't popular when it was first released. And they went and watched it, and they came home, and I just remember them going, it was the most amazing movie we'd ever seen. There was nothing like it ever before. Took like anything that we knew about Star Trek and just blew it out of the water. And so my parents told me and my sister, when we get back to Arizona, we'll go see this Star Wars movie. And it was like, oh, okay. Well, in about 6 or 7 days of Star Wars coming out, people were waiting days in line to see it. I mean, it wasn't like here where you have 56 movie screens and you want it in 3D and 4D and 19D and whatever D you could think about. It didn't exist. So in Arizona, there was one movie theater in Arizona that had the movie. It was the Seneca Prairie, which was the largest movie screen in the state of Arizona. And it sat like 500 people in the theater. It was a huge theater. I remember getting there at 7 o'clock in the morning and waiting until 5 o'clock at night in the same line. Because you didn't go online, because it didn't exist at the time. The military still had all that stuff. And you couldn't buy your tickets in advance. You had to wait in this long line, and then you get up to the movie window and be like, okay, 4 for this movie. Okay, well, we only have 2 left in this theater for this time. So you'd have to figure out whenever the next viable time to see the movie was. And then they would have these corralled off areas when you are for the 2 o'clock feature, you're for the 5 o'clock, so you stay here. You guys with the blue tickets stay here. You guys with the red tickets stay here. It was crazy. So anyhow, it was exciting at the time to see. I love that my kids loved the whole series, and I thought this Rogue One filled in a whole lot of gaps that I had with, things that I always thought should be, and it's always kind of good when I think it should be a certain way, and then they backfill it in the actual movie, and it's the way I thought it should have been. So it's all about me that way. So it's all full circle. So let's talk about a few things. I think the geometry classes that I have all did very well as a whole for the semester. So what would you change about what last semester did? Well, if you look at your semester grade and you're like, dude, I really thought that was an awesome grade, don't change a thing. Keep doing what you do. Things that I will know about second semester, my opinion is, and this is every year of my teaching, second semester goes quicker than first semester. We're a few days into January, obviously, but we're going to hit May pretty quick. Even though we don't have, it seems like a longer period of time. I actually think this semester is a few days longer than first semester. It goes fast because there's different testing days that are in there. We have spring break in there, obviously. We have a couple of holidays. coming up. We have one this month on a Monday and one next month, and then you guys have we have an in-service day, which is when you guys get to sleep in and all the teachers get to come here and hang out going, gosh, I really miss my students. So those are just things that are coming up, but I can tell you that this semester is a rapid moving semester. I'm not going to teach you more than what I had taught you. I'm going to teach you different concepts, obviously. But I think this is a semester where if you are satisfied with what the grade you earned first semester was, keep doing what you're doing. If you think that you could do better, change what you did. Don't expect that, oh, well, I'm going to keep doing what I'm going to do and expect that the C that I earned turns into a B or an A. You know, if you keep doing the same thing over and over and over again and expect different results, that's classified as anybody? Insanity. Crazy. Yeah. So, few things. I don't have the med class this semester. So this doesn't happen this semester. It happens in the fall. I am available, so just so you guys know, before school every day now in my math office. I'm available first period, third period, and fourth period, and that is pretty much it. Okay? My other part of my job has a lot more of stuff that I'm doing off campus. So after my sixth period class, I'm pretty much off campus, which is fine. But I just want to be honest with you that if you want to see me, you know, if you say, oh, I can only come in after school, well, I think that means you're waiting for a ride. Therefore, you probably have a ride that would get you here before school. I usually get here by 6:15. And that's just how I roll. So if you feel that you want to come see me for help, or if you want to come and do your homework at 6:15 in the morning or any of those other times because you don't want to do your homework at home any longer with your math homework, please come see me. And I think you all know where my office is, just around the corner. But, so that's a pretty good amount of opportunities that you can definitely get help. Hopefully that would work for you. If those times don't work, there's all types of other things that are on campus that are free. There's the tutoring in the math science resource room. There's the tutoring that's in the counseling office. There's, pretty much anybody in my office would be willing to help you if you wanted to come in for an occasional question here or there. So, just think of it that way. And if you are so desperate that nothing's working for you, then the other part of my schedule you might be able to work out from time to time, but don't dwell on that being the only time, okay? Sound good? I hope you all had a nice time over your break. But we're going to jump right back into doing a little bit of math. I was asked, do we need to keep everything from first semester? This is me. This is me talking and solely me, so take this for however you want. I have pretty much never in my life gone back to a previous semester when I was in school to look something back up. So I will tell you that if you choose to recycle, I think it'd be nice if we recycled. I mean, yes, if we throw it in the landfill, the paper will break down over about 6 or 7 years. So don't really feel too bad about it. The trees have already been cut down. Need one more? Okay. I'm coming back. So I would think if you don't want to walk around with the binder that's now the 3-inch binder that turned into an 8.5-inch binder because everything's stuffed into it, I would think it'd be good. Yeah.
Is there another workbook that we have to buy?
No, I think we're set. I think the one that you bought it's all there. So I would think that you probably could take the first 5 chapters, and if you want to hang on to it, just put it in your drawer at home on your desk. Need one more? Yes, please. I do have some you can borrow, but I don't necessarily. It's not a class set, so if you have it, please get it. If you need one, get one. I've seen that most of the combinations to the lockers are still on the tape on the bottom. So if you needed to, you'd probably just shop it for yourself. I'm not telling you to steal. I'm just kidding. So
there's a way you can open locks with Coke cans.
with Coke cans?
Yeah. If
you listen, then you can flip.
Oh.
It's like you have to like.
Yeah, but haven't you seen on the bottom, like almost everybody has the tape still on the bottom that has the combo on it. You're supposed to remove that tape.
I don't think mine's from It's down the hallway.
Down the hall? Okay. Do you have a TI-83 in there? You have it? Yeah. That's where you get one. Okay. I'm just kidding. So, but that's where we're at. Okay, let's figure this out. Back to the beginning of this, see how we do. So, are we doing proofs? Not today. Oh, I know most of you're probably so excited, going, "Can't wait for the proofs."
Crazy.
I think, I mean, honestly, when I go back and I look at last semester, what y'all did, you guys are top notch. So go home and give mom or dad a high five and say thanks, because you guys are awesome. All right, ratios and geometric means. Extend the previous understanding of ratios, develop an understanding of a geometric mean, and apply both to find the missing measures. Okay, ratio, it's a fraction. Why don't we like fractions? Because fractions is another way for division. Didn't like division either. I know. But you guys all did fine with it, so we'll move on. What do you remember about ratios? Part over whole, right? What else? Let's see, is this a pull thing that I can pull here? Yeah, there we go. Comparison of two quantities with the same unit of measure. 2 out of 5. It's 2/5. Does it have to be the same unit of measure? No. Ratio could be, your velocity, miles per hour. Okay, when you say, hey, Pastor, we're doing 70 miles per hour, but you'd be more impressed saying, dude, we're doing 210 miles every 3 hours. Yeah, we're going fast. Yeah, you're still only going 70. Which I guess is fast. Okay, so comparison of two quantities. Here we go. We're trucking. Okay, make sense so far? Can I move on? Can we write the ratio of 5 to 15? If I tell you that the ratio of the length of the width of a rectangle is 3 to 5, can you tell exactly how long each side is? I think we're missing a little information if we did that. But if I told you the ratio of the sides of a rectangle are 3 to 5, and I gave you the perimeter, then you could probably go through algebraically and solve it. Let's see, you should have all those notes. Is there anything I should pull on these? If I tell you, no, nothing there, nothing over there. All right, cool. Write the ratio of 5 feet to 20 inches. Are the measures in the same units? So is it 1 foot to 4 inches?
60 to 20.
Yeah. So
3 to 1.
So one of your biggest friends as far as math and science goes is dimensional analysis. So if you were to take 5 feet over 20 inches, you would need to put those both in feet or both in inches. So some people might say, oh, well, I'll multiply that by 12, so I'll get 60 inches over 20 inches, which is 6 over 2, which is 3 over 1, inches to inches. Write the ratio of 150 centimeters to 6 meters. Again, they're not in the same unit, are they? Then you have to start remembering, okay, whoop, that should be meter. Sorry about that. All right, so what do I have to do to change meters to centimeters or centimeters to meters?
Multiply by 100.
Multiply by 100. So if you multiply the bottom by 100, 150 centimeters to 600 centimeters, reduce where you can. Okay, if you were to change those both to meters, that'd be fine as well. Boy, we would be an incredible nation if we would all just realize metric system's a really good thing. No, it isn't. Yeah, it is, because you're only dividing or multiplying by 10 or factors of 10.
Why do we even have a code measurement?
Because we're too cool, supposedly.
We have to be unique.
I know of a $1 billion mistake that was made because we were too egotistical to think that there is another unit. And before we put the Mars rovers on Mars, we sent one to Mars that we lost contact with, and then they realized, oh, all of the programming was done in English units, and you guys gave us all the metric. And so what did happen to the thing? It either crashed into Mars or bounced off Mars and went somewhere else. We goofed up. The area of a rectangular garden is 108 square feet. You guys following along in this story? The ratio of the length to the width is 4:3. Find the length and the width of the garden. First, sketch a rectangle and label the sides. Length, width. Yay. Remember that? So how am I going to do it?
Put 4
4 where?
with the L.
Just 4?
Well,
Just 3?
well,
Because
no.
4 times 3 is only 12.
Okay, 4
12 and
108 divided
12 and 9? Where are you getting 12 and 9?
4 and 3 are a ratio.
108 divided by 4.
Wait, I got too many people talking. Talk first. Go ahead.
Okay, so I would assume it'd be 4x times 3x equals 108.
Then let's see if that way works. I get 12x squared equals 108.
And
Anyone
then
got a
divide by
calculator?
12.
That's 11. 9? X equals plus or minus 3. Which one can we eliminate? The negative, because it's a length, correct?
So it's 12.
Like I said, I got it. Okay. Other ways to solve it? I heard some other guess and check. I like it. Guess and check works awesome as long as we come out to whole numbers and don't come out with weird decimals or fractions. Huh. Is 12 times 9 108? Last time I checked, I thought so. But that might have been so last year.
Why?
Huh. That seems all right. The measure of the angles of a triangle are ratio 2, 3, and 4. Find the measure of each angle. So what do all 3 angles of a triangle have to add up to? 180. So you have 2x and 3x and 4x. So 2 plus 3 plus 4 is 9x equals what? 180. So divide each side by 9. So I find that x is equal to 20. So this angle is 40. This angle is what? 60. This angle is how much? 80. If I add 40, 60, and 80 together, do I get 180? Sweet. So some ratios work that way. All right, moving on. What do you remember about proportions? What's the way to solve this if we have x on top or x on bottom of a fraction? What are we doing? Cross multiply. And cross multiplication always is the verbiage I would like to use. But I will tell you that there's other math people out there that will tell you that it's the products of the means is equal to the products of the extremes. What? And I don't know why the math folks can't get over the fact of cross multiplication means the same thing. Kids understand cross multiplication. Okay, so if I cross multiply 15 times x is 15x, right? And 8 times 2.5 is? 20. Is that right? Okay. And then divide each side by? So 4 over 3. To make y'all happy, this started out, I get a fraction with a decimal, which is like, dirty math, but hey. So that would mean I could put 1.3 repeating forever in for x if I wanted to. What if I cross multiply here? Sweet. Hey, I got a quick question for you. I know I had this conversation with y'all around Thanksgiving time. That is 99.9, 100%. What did I say? I said no, and y'all got mad at me. When y'all took a look at your grades, did 99.9 equal 100% in my book? I will tell you, there's some of you that probably should have had a C if I had abided by that. So that 79.9 helped you. So y'all got all mad at me because you're like, thought I was a bad person. I was just trying to be honest with you. Huh? Doing what's right. The nice thing is there was more of you that had a nice solid grade that didn't get affected one way or the other. There's only a handful of you that came down to the 79 point or the 89 point, the 69 point. Yeah. 69.2.
They got a solid 80%.
See? Good job, Sammy. All right. How do you find the mean of two numbers? Add them up, right? The mean, if I were to find the mean, that means I'd add the two numbers together and divide by 2. Why 2 in this case? Because I have two things. So this would be 42 over 2, which is 21. So the average is 21. Now, I will tell you that here's your statistics lesson for the day. If you have something called an outlier, the average or the mean is not the measure of central tendency you want to use. You want to switch to the median, which is not influenced by the outliers. Okay? So what this basically means is this. I live in Littleton. I live really close to Powell Middle School. Powell Middle School is the main middle school that feeds into Arapahoe High School. Sorry, I live in a trader's neighborhood for you guys. Sorry, we keep beating them at sports, so it doesn't matter. But a lot of people from Douglas County, because things are silly down there with education, chose to open enroll their kids in Littleton Public Schools. And Powell Middle School has a waiting list of over 900 people trying to get in. Yeah. Now, they won't take all 900 people. In fact, it's gotten to a point now that the housing market in my particular neighborhood has gone nuts, and people are choosing to leave where they're living, buy homes in my neighborhood, which is jacking the price to craziness, and which is great for me if I choose to sell. So, but my problem is I love my house. I love where I live. But I contacted the city, and I said, I think we have a problem with people who are speeding through the neighborhood to drop their kids off at middle school. So they sent out the data collection machine, which shows your speed, and it logs how fast you were going, and then they get the data on it. Well, being that Powell Middle School is right on the little boundary of Littleton and Centennial, they both shared the data with the traffic engineers of both cities. And then they made the mistake of sending me the data and what the data said. They didn't do it correct. And there's two traffic engineers that I was pretty blunt with, saying, I can't believe you can't figure out basic mean. And then they finally admitted, oh, we threw out the outliers. So they threw out the people who were speeding. And then they did their data. So the mean's not a good thing to use because it gets influenced by outliers. So if you wanted to check what, say, maybe out here, how fast people are going, you toss out the outliers, you're going to find that it's probably pretty close to 25 miles per hour for the most part when it's a flashing school zone. Are there the people that are blasting through it because rules don't apply to them? Yeah.
Do people get a ticket if they cut their neighborhood?
No. I was just trying to point out that we needed to have a flashing school zone sign coming through the back way through because they realized, oh, if I come through the back way, there's no flashing school zone.
We have a sign right outside the entrance of our neighborhood saying that you can't cut through, but people cut through and they end up getting stopped by the police and get ticketed.
Yeah, there you go. Yeah. The cut-throughs, they don't have the cut-through thing in mind, but it's, I found a point, like every time you talk to a kid that would be walking to school, like, yeah, I almost got hit by a car that was speeding. And you'd be out there going, okay, it's 25 miles an hour, they're going kind of fast. So, all right, now we have something called the geometric mean. Anybody know what this is? Geometric mean means we're going to set up a ratio. A over x equals x over b, where x remains x, and a and b represent the two numbers you're talking about. So if I did this correctly, I'm going to get 12 over x, still with me, equals x over 27. And how do I solve this? Cross multiply, so I get x squared. Somebody with a calculator, tell me what 12 times 27 would be. Is it 324? Root that. X is equal to plus or minus. Root of 324 is? Sure. 18 exactly? So our answer here is actually just 18. Okay, so is 18 the mean? In this case, it's the geometric mean. If I wanted to find just the regular arithmetic mean, I would take 12 and 27, add it together, and divide by 2, and you would find that becomes 39 over 2, which comes out to 19.5. 19.5 as the arithmetic mean is a lot different number than 18. Do you agree? Yeah. So the geometric mean means you're setting up a ratio. You're going to have to take the square root of. And most times you will keep the positive component, but please realize that the plus or minus does mean something in the world of algebra. Sometimes you need to simplify the answer, simplify the radical form. Find the geometric mean of 16, 18. All right, so the geometric mean of 16 and 18 is x over 16. Go back to my pen. X over 16 and 18 over x. Cross multiply. X squared equals 16 times 18. Help me out. 288. Root. Plus or minus 12 root 2. I think I just got 12 root 2. But you got what? 16 what? Yeah, so what I would have done, being I recognize 288 is the same thing as 144 times root 2. That becomes 12 root 2. And that becomes an exact answer, which if you make things exact answers, they work out nicer for you later. So what is the arithmetic mean of these two numbers? 17, right? Is 17 the same number as 12 root 2? No, and it shouldn't be. It's pretty unlikely that if I have you find the geometric mean and the arithmetic mean, that you'll get the exact same number. Is it possible? Absolutely. Can I give you an example right off the top of my head? No. Sorry. Seem okay so far? Yeah.
So it doesn't matter which number you put like, for the
Oh.
geometric mean, like which one goes over x.
No, I mean, and I could have even had this. That's still going to work out the same. Cool? Find the geometric mean of 54 and 18. I need help. 54 in more than one way. Cross multiply. X squared equals 18 times 54. Help me out.
972.
972. Square root of 972. 31.1 exactly, or repeating?
31.2.
Keeps going and going. Okay. So, pretty close, yeah. Find the geometric mean of 36 and 54. Oops. Cross multiply. What's 36 times 54? What is it?
1,900.
That? And then root of that, I get what?
44.09.
44.09. So 54 and 18, 36 and 54. 54 is a common thing, but look how much closer these two numbers are to each other. Pretty easy? I hope it is. The geometric mean of 12 is, and x is equal to 6. That's 12 over x equals x over, no, did I do that right?
No, X.
12 over x plus x over b equals 6.
The geometric mean are two numbers,
Oh.
so I have a over b, or a over x equals, oh man, I'd be such a better teacher if I could think through things. 12 over x, and x over something, and the result of this would be 6.
36 times 3.
Oh,
It's
that's
three.
just 3.
It's 3. It's
Oh,
3.
yeah, it's 3.
It's 3.
It's what?
It's 3.
It's 3. So, what's the relationship here? This would be 12 times question mark would equal 36. Agreed? So question mark equals 3. Right? Because this and this should both be 6 and 6. If you cross multiply, it's going to work out nicely. Oh, now we have a root in there. Not going to do it. The geometric mean of 10 and x is 5 root 6. Uh-oh. So let's see if I can do it this way. 10 over 5 root 6 and 5 root 6 over x. All right? Cross multiply. 10 times x is 10x. 5 times 5 is 25. Root 6 times root 6 is root 36, which is 6. So 10x equals 150. Is that right? X equals 15. Is everyone okay with how I cross multiplied here and here? 5 times 5. So 5 root 6 times 5 root 6. The 5 and 5 get multiplied. The root 6 and root 6 becomes root 36, which is the square root of 36, which is 6. Woo! Can I go? Questions? Show as much as you possibly need. Yeah. Do you want? So, are you having trouble here? So, if I do this, I'm going to go 5 times 5, I get 25, times root 36. Root 36 is 6. Cool?
Wait, so our homework is
6.1, yeah. Is that a worksheet that's in your book, I hope?
Yeah.
Sweet. So, just a reminder, guys and girls, I'm giving you the opportunity to start on this. The nice thing is, if you get a start on it and you happen to get it done between now and the end of the period, you walk out of here with pretty much nothing to do tonight for as math goes. And I was asked, do I have a sheet for this semester? I haven't been given one yet, so hopefully I'll get there. Looks like we got proportions, more proportion, similar polygons, and similar AA.
Yeah, it's the same.